Okay, good morning students. So in this class we are going to see motional EMF. So the last class we have already seen what is the electromagnetic induction, how the induced current is produced in a circuit we have already seen. So now we are going to see motional EMF. We start with our discussion with electromagnetic induction. So we have already said how to change the magnetic field. The conductor is moving though the magnetic field, or we change the magnetic field, induced current is produced. We have already seen. So now we will see. So one magnetic field is here. So this is the magnetic field into the space. So one conductor, I have considered one conductor is here. So one conductor is here. This conductor is moving with velocity v. So moving with velocity v 0 to L. So I consider, so in a magnetic field, one conductor is moving with velocity v. So this is the length of the conductor L. So what will, first I consider when the conductor is moving, the inside the charge is also moving. So I consider initially plus charge is moving inside the conductor. So plus charge is moving inside the conductor, plus charge is moving. So if the plus charge is moving in the magnetic field, we have already know that is a magnetic force is created. The magnetic force is equal to QVP. So magnetic force is created FB. So this is the magnetic force is created FB. So what this forces do, this forces causes the charges, moving charges, and separate the charges between the end of the conductor. This is the thing the magnetic force do. So because of the magnetic force 0 to L, this is the magnetic field. So conductor is here. So magnetic force is acting upward direction. So this magnetic force is separate the charges. So plus charge is upward. So minus charge is accumulated downward. So because of the separation of the charges, we have already known the electric field is created. The electric field is moving from positive charge to negative charge. So what will happen here? So electric field is moving from positive to negative. So because of the electric field, electric force is created. The electric force is directly opposite to the magnetic force. So by here, so magnetic force, electric force is acting downward direction. Okay. So the charge is moving more and more. Electric field is created inside the conductor more and more. This will happen up to the two forces are equal. That means electric force and magnetic force they equal up to level. The electric field is moving. That means charge is on the flowing. That means electric field is flowing. So this is the condition. So at this time, so by electric field, electric force equal to, so magnetic force. So electric force equal to, so magnetic force. So electric force we have already known. So equal to QE is equal to, so what is the magnetic force? QVB. So QQ we can cancel. So by electric field E is equal to VB. So when the conductor is moving at constant velocity in a uniform magnetic field, so this much of electric field, so E equal to VB, this much of electric field is created due to the magnetic force to separate the charges. Electric field is created inside the conductor. So this much of electric field is created inside the conductor when the conductor is moving through the uniform magnetic field. So now we have already known what is the relationship between electric field and potential difference we have already known. So this electric field. To this electric field, potential difference is created between the ends of the rod. So this is 0 to L coordinate system. But this is the magnetic field. So, but this is the potential difference del V. So, but this much is potential difference is created between to the electric field between the ends of the conductor. So, this potential difference relationship we have already known, but del V is equal to potential difference at the top minus potential difference at bottom. So, but this is del V is equal to, so integration minus 0 to L. This is the direct formula we have already, I have already derived this formula, the relationship between potential difference and electric field. So, by E y into dy. That means electric field is downward direction, y direction, that is why I put it y. So, E y into dy. So, but this equal to minus 0 to L, integration 0 to L, E. So, E value VB. So, the direction of EY is equal to minus VB into dy. So, why I put minus, this electric field is acting downward direction, that is why I put it minus. So, minus VB into dy. So, VB constant, B constant, we take it out. So, minus into minus plus. So, VB integration 0 to L into dy. So, but that's why. So, VB, this is upper limit, this is simple integration. We put it upper limit minus lower limit L. So, by VBL. So, this is the potential difference. So, when the conductor is moving through the magnetic field at constant velocity, this much of potential difference is created between the ends of the wire. So, V del V is equal to VBL. So, now we can take the idle battery. In idle battery, without no current, the EMF is equal to potential difference between the battery. So, we have already studied. So, by EMF in the idle battery, epsilon is equal to del V. This is the idle battery. So, this is the electromotive force in idle battery. So, if we analyze with that in idle battery, so here the conductor is, the moving conductor in a magnetic field acts like a battery. So, this EMF is created in idle battery, this EMF is created due to the chemical EMF. This is a charge separation work done per charge. Due to the chemical EMF, the charge is created. But here, due to the magnetic force, the charge is separated between the ends of the conductor and created potential difference, this much potential difference. That is the difference. So, we can directly write the motional EMF is nothing but we can define like this. When the conductor is moving the velocity V in a perpendicular to the magnetic field, epsilon, the electromotive force E is equal to, we can write BVL. We can write VLB. So, VLB. So, but this is the motional EMF. Because of the moving conductor, magnetic field, magnetic forces create the charges between the two ends. So, like that is exactly how the magnetic potential difference created in the idle battery. So, from this analogy, we can write the motional EMF is equal to VLB. This is called motional EMF. Now, we will see one small numerical example. See, one conductor is here, one magnetic field is here. So, one conductor is rotating. This is the bivolt. This conductor is rotating in a clockwise direction. The question is, how much potential difference created between the ends of the rod? This is the question. This is the magnetic field. We have already known when if the conductor is here, the conductor is moving straight, instead of their conductor is moving rotation, even though the charge is also moving perpendicular to the magnetic field. So by electric field is here, positive charge is created, here negative charge is created, electric field is moving from positive to negative, electric field is moving from towards the bivolt. The velocity of the charges are increase with respect to r. So here electric field is very high, here electric field is very less, and the charge is also, moving charge is also a difference between with respect to the distance. So we have already known, so by E is equal to electric field, E is equal to V, we can write E is equal to VBL. So by VBL, electric field is equal to VBL. So we put it, this length of the conductor is L. So for potential difference del V is equal to minus integration 0 to L. So electric field E into dr. So electric field is this acting towards the radial center. So ER into dr. So ER is nothing but electric field is acting towards the center. So minus VBL we can write. So this is minus, I put it minus. If we take it minus into minus plus, so by integration E into, so integration 0 to L. So VB, so minus VB R into dr. So this is the distance. If I take distance up to distance R, so VB R into dr. So here minus into minus plus will come. So integration 0 to L. Here plus VB we can take it out. So by VB R into dr. So if I put it, the final answer R into dr means the r square by 2. If we apply upper limit minus lower limit, our final answer will come. So by VB L square divided by 2. So we can, V is equal to, this is the tangential velocity. The rod is in the rotating. So we can compare with the tangential velocity with the angular velocity. V is equal to R omega. Instead I am going to put it R omega. So for R omega, so answer will come like that. So potential difference del V is equal to 1 by 2 R omega L square divided by 2. So R omega L square divided by 2. But this much of potential difference is created between the ends of the rod. I hope you understand well. So next class we will see what is the induced current in a circuit and how to find out the power. So all those things we will see. Thank you.